Hello there, my name is Tero Hannula and today we will start our day by making neural network with the GameMaker Studio 2. This is first part of the video series and during these videos we will make feed-forward neural network which can learn and make predictions. Note that I'm not expert in the subject and I have learned this stuff by self-studying, therefore I might get some things wrong or do things in an unusual way. But anyway, we will start by making forward pass, which is used to make predictions. For this, we need to create, store and modify information. After this video, we will have a network, which can take input signal and propagate it through the network to give a result. But because network is not trained, these results will be random. In the next video, we will do backward pass, which is used for training. In these videos, I will be using latest stable version of GameMaker Studio 2, which is currently 2.3.3. But this should work in any 2.3 version. If you are using 2.2 or earlier, it will be a bit harder to follow, but I think you can emulate the structure and methods with instances and user-defined events. There are many ways to create neural networks, so do not take my approach as ground truth. I will try to make my code a little bit more expandable, so you can add more stuff, as I will not cover them all. And remember, as we progress in videos and add new things, we might also change previously written code. I would like to explain this as we go, but I'm not good at talking, so instead I will do small voiceovers. And please put on subtitles, as I will make more accurate explanations over there. But now, let's get started. Our network will be built upon different layers. First, I will make a base layer, which all other layers will inherit. In today's video, I will create only two layer types, input and dense. These are enough to get going. With the base layer, we avoid repeating same code all over places and make sure some variables exist within all layers. First actual layer type would be input, which is used as a first layer for a network. This will be different from other types because there is no previous layer, so user needs to provide input source themselves. This layer will accept array as source for neuron activities, but we can add new layer types for other data structures. Second type we make today is dense layer, which is also known as fully connected layer. You can imagine that all neurons are connected to every previous neuron where the name comes. These connections are called weights because they put different weight upon the same signal. So in this layer, neuron activity is calculated as weighted sums of previous layer. Activity is further modified by activation function and bias. In dense layer, weights and biases are learnable parameters, and they need the starting values, which should be random. There are many ways of doing this, and it can greatly affect the learning of network, but I'm not going to dive into that. So I'm going to take easy route and just use KMaker random functions. So, in dense layer, neuron activity is calculated as a weighted sum of previous layer, added with a bias. To get final output signal, we use activation function. This is usually done to make activity non-linearly correlated to original signal. Otherwise, network could only solve linear problems. We will create few activation functions in this video, but the reason for storing them in global array comes in the next video. Now that we have done the layers, we will create a constructor for operating them. We will also have a separate layer builder, which makes adding new layers more convenient. So, user will not directly touch either layer constructors or methods. Instead, these structs will handle it for them. Today's goal is to be able to get something out of the network. For this, we will create two methods, input and forward. Input is for updating first layer neuron activities, and forward is for making predictions by propagating signal from first layer to the last. We will make a layer builder so we can optimize updating network information and make sure layers are correctly added to it. In here we will create methods for all usable layers, so user will not need to use actual layer constructors. We will keep all available activation functions in this script file, and today we will create identity, Tarn, Sigmund and Relu. I chose these as they are commonly used ones. We will identify all activation functions with our enumerator, which needs to be updated if you add new ones. Identity is just a pass-through function, which could be used whenever a user has not chosen one. We will store and access all available functions in global array. This way, layers only need to know identifier, which is used to find correct function from array. Furthermore, identifier will have other use cases, like in the next video finding derivatives or when we want to store our network. Now we have made necessary scripts for making predictions, so I will show you few ways you can operate the network. I will create an example object for this. You just create a network like any other struct. Then add new layers by calling builder methods, which are behind id variable. To make prediction, you need to update input first, and there are a couple of ways of doing it. To get prediction from forward pass, you either store return value or access output of last layer. We want to visualize our network somehow, so we can see it is working and it is giving some results. You can do this however you want, as it is not necessary part how network will work. As you have seen, there will be a lot of loops and calculations, so I would recommend using YYZ compiler whenever you are exporting your project. This will bring more performance compared to virtual machine. But what we will make here will be slower than writing native C++. If you want to stay pure GML, you could use dsgrids instead of arrays. This way you can utilize region calculations, which in my experience will be faster. But for these videos I chose to use arrays, as they are easier to understand. You can try replicating these in C++ and then make extension for using them in GameMaker. I might show that later, as I have not decided how many videos I will make. So that's all we will write for today. What we have done here is first layer types and activation functions, layer builder and network to operate them. Currently we can create network and send signals and visualize them. But we cannot teach our network just yet. In the next video we will make a backward pass. For this I will introduce you to backpropagation and gradient descent, which are form of supervised learning. Shortly put, we have input-output pairs as our examples. We show input to network which does the prediction, and we compare this to target output of example. But those are things for other day, jotenpä nähdäänpä silloin ja hyvää päivänjatkoa. Heippa!